All right, ladies and gentlemen, welcome to part two of chemical bonding. So this week we'll talk more about a different type of way that atoms bond together, which is covalent bonding. But before we do that, just recap, right? Just a review of why we chemical bond. Remember, it's the idea that all atoms want to be happy, right? And what that means is the outer ring is completely full. So last week we talked about the idea that um, that ionic bonding was the giving and taking of electrons, right? One of the atoms gives away its electrons to get to zero, and the other atom takes electrons to get to eight, right? Both ways does exactly this, right? Which is to get all the atoms happy, all right? So we already went over this. So let's go over now the new way that we can do, and which I think is a little bit easier to do, which is covalent bonding. All right. So last week ionic, right? Give and take. This week the idea is that you also have atoms that don't just give and take electrons. What they do is they share electrons, right? Um, and the idea is that when they, and I'm gonna highlight this because it's a key word right there, is that they share the electrons between one another. So like one of the atoms doesn't actually give away its electrons, like here, right? What they actually do is they kind of share between the two as you're going through. And it kind of creates like a little bridge between the two. There's like a little force field or like a kind of like that's created behind around it that allows for those two electrons to pass between one another back and forth, right? As we're going through it. So it kind of goes through that. Now, in covalent bonding, um, unlike ionic bonding, it only occurs between nonmetals. All right, this is a big part. So metals can't be a part of covalent bonding. It can only be nonmetals that are part of that. So yeah, so that's how it kind of works out. So I'm going to go over some examples as to how you would show covalent bonding compared to how you did ionic bonding. All right, so the first example I have here is how hydrogen and iodine chemically combine through a covalent bond. Now, we wouldn't go through an ionic bond because the first thing is, right, when we look at the periodic table, both the hydrogen and the iodine are both nonmetals. So I know that it's going to be a covalent bond. All right. So first thing, just like last week, right? Just like anything else, we always have to first start with figuring out the electron dot diagrams for each one. That's the reason why that week was a huge week, because it relates to all this stuff. So we looked at hydrogen over here as one valence electron, and iodine over here has seven, right? Because eight and then seven. So let's put those around it. So, oops, the H kind of flew away. All right, so H is right here. So I have one valence electron around hydrogen, and then I have two or seven around iodine. Okay. All right. So last week when we talked about this, we said that hey, in ionic bond we just did this, right? But in a covalent bond, what we have is more of a sharing electrons. So in each case, both atoms are still going to get to an outer ring that's full. It's just instead of hydrogen giving away its electron over here, right? What happens is they share their electrons between the two. And I'm showing the sharing by using rubber bands, right? So in your lab this week, if you have rubber bands, you can use that. If you don't have rubber bands at your house, you can easily just go like this between the two to show that they're now on kind of connecting their rings together. But if you have rubber bands or something that you can put around it, it would really be helpful to do that. But basically the idea is when you do this, this iodine right here now has 8 valence electrons. It goes 1, 2, 3, 4, 5, 6. And I would count this kind of bridge, 7 and 8. So this right here, right, or the hydrogen, will give or will loan its electrons over here for a little bit, right? So iodine has it for a little bit. And then what happens is iodine goes, all right, I've had it for a little bit. Hydrogen also wants its full outer ring. So this one goes over here for a little bit. Now, some of you guys might be saying, wait a minute, hydrogen only has 2 valence electrons. Doesn't it need to have 8? The answer is no. Remember, hydrogen is one of those special ones, right? Since hydrogen is over here, it's in the very first period. Remember when we were making our atoms, the very first ring only had 2 valence electrons to be full? Well, that's because remember, it has only 2 elements in the very first period, so it only needs 2 valence electrons to be happy. So hydrogen is happy with only 2. And so this one works. So that's the reason why hydrogen is one of the easier ones. And you'll notice that hydrogen is in a ton of covalent bonds because hydrogen is one of the easiest atoms to combine with because it only needs 2 valence electrons. Okay, so here's how hydrogen and iodine react together. So it looks a little bit different. Now, reason why I think that covalent bond is easier to show is because since electrons are not given and taken, I don't need to put brackets around it. I don't need to put positive and negative charges because they're sharing them between the two. So they go back and forth really, really fast. So you never really know whether or not the hydrogen actually has the electrons or the iodine is actually sharing these electrons because it's happening so quickly. All right. So that's all you have to do, which is so much, I think, easier than the ionic bonds and so on. So get rid of the brackets and all that stuff because you don't need that for this week's covalent bonding lab stuff. Okay. So this is how I would do HI. All right. So take a screenshot. Remember, my expectation is in your notes. You are screenshotting this because that's the bulk of the notes is how to do these things. All right. So let's move on to the next one, SE and SE. All right. So, all right. And oftentimes what you'll notice in covalent bonds is that a lot of atoms like to combine with their own, like the same type of atom. Right. So a lot of times you'll see like H combining with another H, right, like this, or you'll see like chlorine and chlorine or oxygen and oxygen. Here we have selenium and selenium combining together, right, to make Se2. Remember that 2 right here means ultimately there's 2, right, atoms combined. So just like always, right, no matter if it's covalent bonding or ionic bonding, we always look over here on the periodic table. Now remember, since selenium is a non-metal, right? That's the reason why we're doing a covalent bond, right? If you actually try to do an ionic bond with Se and Se, it won't work, right? The 2 atoms won't be happy with one another, right? So you always want to make sure that you know if it's a metal or a non-metal to begin with. So Se and Se has 6 valence electrons, right? Because it goes 8, 7, 6, right? So let's put 6 valence electrons around each one. So 1, 2, 3, 4, 5, and 6, right? 1, 2, 3, 4, 5, and 6. All right, so we have 6 and 6 on each other, right? As you're going through it. So what I'm going to do here is, if you look, right, we're going to be combining electrons. Remember, the whole point is we're trying to get to 8, right, on both sides. So instead of, remember, giving electrons away, right, and I actually should use green on this one, just so you can see, right? Probably be a little bit easier to visualize the difference in which one goes where. All right, here we go. All right, Se and Se. All right, as I go through. And the thing that you want to look for in a covalent bonding is you're looking for, hey, these are paired up. And this is the reason why we kind of do this, right? In the electron, we have paired ups, paired up, right? What we see is the ones that are not paired, right? The ones that don't have 2. And what you do from those is that's where you put the rubber bands around because you see that they're not paired together. So the rubber bands pair those 2 apart, right? Same thing with the next one, right? We see that. Now I'm going to use a longer rubber band because these 2 need to be around each other like that, okay? I know a lot of you guys are going to try and do this. This doesn't work, okay? In those bridges, you can't put like all those together. Okay, you can only bond 2 electrons at a time. So they're always working in pairs. All right, so when you see something like this, make sure that only 2 go into, right, the rubber bands together. All right, so now if I count it right, what happens is I go 1, 2, 3, 4, 5, and 6, right, because I'm counting everything in the rubber band, 7 and 8. So this selenium now has 8 electrons, right? This selenium also goes 1, 2, 3, 4, 5, 6, 7, and 8, right? So they're combining or they're sharing these electrons together to do it. So like both seleniums are going to right, want to hold on to their electrons. So they're not giving or taking electrons like we did last week. What they're doing is they're sharing amongst each other. But now electrons move at the speed of light, which is really, really, really fast. So when they go back and forth between the two, you're never going to really know the difference. So that's the reason why this sharing thing really, really works well, because even though the selenium might lose its electron over here for a little bit, right, it comes back like this. So both are really, really happy all the time. Now this is what we call a double bond. See how there's two bonds right here, right? So whenever selenium gets together, there's two bonds that are created. All right, that's the reason why we can't do this. Okay, all right. So you got to make sure that you only put two valence electrons in each one of that. Now, if you don't have a really long rubber band like this, right? All I did was I took two rubber bands and I just kind of intertwined them together. If you don't know how to do that, you can always go like this. If you really, really are going, I don't have a long rubber band or a long something, that works too. I think it's sometimes easier to see it if I don't have to move the valence electrons back and forth like that. So it's up to you how you have it. If you have longer rubber bands, great. If not, you can always daisy chain them together to kind of do it. Okay? But that's it. That's all you have to do for covalent bonding. But remember, with any kind of bonding that you have, right, no matter what, you want to make sure that all the atoms are combined together to make a covalent bond, right? Or I'm sorry, to make the outer rings full. Because if you try to do this as an ionic bond, it wouldn't work, right? Because in an ionic bond, one would have to go to 0, one would have to go to 8. That wouldn't ever work in this situation because this selenium would take 2, but then this one was left with 4, right? So that's the reason why this has to go through a covalent bond. Cool? All right, let me put that back in. So make sure that you take a screenshot of this, put this in your notes. That's all we have for this week. So the lab really deals with this. Cool? All right. Also, last thing. I'm also putting out, this has nothing to do with this, but the last 2 weeks of this quarter is about the engineering unit. So I'm going to be linking a document where it's an engineering preview. So please take a look at it because there are some like information or not information. There's some materials that are needed, and depending on what stuff you have at your house will depend on what you're going to be able to do for each lab. I'm going to talk more about it on Tuesday's video session. So if you can make it to Tuesday's video session, I'm going to talk a little bit more in detail about the engineering projects. All right, and I'll also talk about it on Friday too. So Tuesday and Friday. So if you can make one of those, that would be great. For those of you who really want to maybe get started on the engineering projects or want to take a look, Tuesday, all right, or you can wait till Friday. Other than that, stay safe. Peace out.